So thank you very much for the introduction, Stefan, and thank you also for Victor for the nice talk. So my part is going to describe about also scalable pipeline for effective forecasts of COVID-19 in Germany, Czechia, and Poland. I work at Casus. It is located at Kollitz. It's a part of Helmholtz-Zentrum Dresden-Rossendorf. I've started my job here in last September. So when I came there, I was introduced a project about the data integration between the hospitals, the school, and the retirement house. And Casus, and this project, we are responsible to make a forecast to predict the daily and weekly situation about COVID-19, in particularly in Sachsen, and commonly and also for other countries, the neighbors countries, for Germany, for example, and for Poland or for Czechia. When I arrive, by the way, so I'm also a physicist, researcher. So I did my PhD at Max Planck Institute, and then I worked for a while in Deutsche Bahn, and then I work in Helmholtz-Zentrum. When I come to Casus, of course, like this project has been already started like 2019. So I arrived like almost 2 years after. And of course, there are many data science there and also postdoc there. But the way they do, they perform, they apply their machine learning method or statistical method is they download the file from repository or Robert Koch Institute. It can be from KIT as well, and then they make like their preprocessing job. And it found that it found that my colleague told me that it was a bit, not a bit, but that's the part of really difficult in preprocessing the data than applying their machine learning tools. And then, I came up with an idea. Why don't we build kind of this database which can consolidate all of the data from many sources? Of course, that using CSV, there's a process, like it's used everywhere. It's easy in large user community. Also familiar user interface and many built-in third-party function, an easy learning curve. For example, if you use pandas or the library in R, you can easily learn in like a month or 2 months. One can be already an expert on it. And it is independent work, and for researcher it is very convenient to work independently because they are trained to be like that, to be independently working, to be independent worker. So, and also quick analysis of smaller data sets. But the problem is like with CSV and XML JSON is not inherently secure. So for example, with this data, the data of retirement house, so we have an agreement like the data cannot be released publicly. So then we have a problem with CSV. I mean, we cannot control who can see this data or not. And then after that, it's susceptible to trivial human error, and it is difficult to troubleshoot and test, and not designed for collaborative work. So I mean, if someone work and develop the model, try to apply to these data sets, example like he or she downloaded 2 weeks ago, and after that she download 2 weeks later, and after that it doesn't work the model again. We have to adapt the tolerance. So this kind of the cons, and it's getting trouble in handling the large data sets. In the beginning of the projects, okay, everything nice when the data set is small, but then when that set is getting large, then they're getting problem. And also not built for the business continuity in mind. So if we have a CSV and something and put in GitHub, it's not for the long run. And then, yeah, like I said, it's expensive in pre-processing data sets. But in my idea, when I came there, in order to consolidate the data from these three things, you need kind of collaborative work. I mean, the data engineer and the data science need to work together. And the data has to be like continuously updated every day and weekly. And it's all also about data security. How do we improve that? Who can only access which data is accessible publicly and which data is accessible only privately. And then it large data sets, of course, like and also less data preprocessing for user and data synchronization. So the data which come from the source, for example, from the Robert Koch Institute, today is also we have the version from the same version as Robert Koch Institute, and also the same version as the one in Poland, the same version as the one in Czechia, and we don't need to download again. So it's just automatically by the machine. So it's like we make like automated things there. And this for this, I see just, I mean, the less expensive one, of course, like if you want to build the commercial one, there is Oracle, but what I've been built so far is like really less expensive one. It's preserve data integrity and process data quickly and store large data sets and have an audit trail on database. The things that the system that I haven't built so far is like the data comes from hospital, retirement house, and school, and then it went through the kind of repository, which is appointed repository. Some of it which is publicly, and some of them which is privately come to us directly, and then with kind of this is not like the fancy one, but this is like the classic method, the extract, transfer, load, and the script has been built here. I mean, it's quite long, so yeah, but it's efficient. And then it transferred to that central database of cases, and with the help of the model of the we kind of make a relational database in order to be prepared for the data science. And then, for example, and after that, automatically it was forecast or it was predicted by the machine learning method. And it was published in the Where to Test website. So this kind of daily activities pipeline, which is performed automatically. And we have built this. Yeah, of course that there were challenges. Like, for example, from every sources, there are various table structures and data sets, and this is also a challenge that we had to face. And also various data file formats. Some of them they prepare in Excel, some of them they prepare in CSV, some of them they prepare just randomly. I mean, we have also to deal with it, and with JSON file, and the third one is data synchronization. How do we synchronize the data daily with the sources? So we can provide forecast real time. And this can also, I mean, the nice facility for the data science. So their job is not pre-processing again. Their job is only to forecast, to predict based on their method. And then what we use to solve this problem, to overcome this various table structures and everything, we use kind of dimensional facts model. So dimensional facts model consists of three things. The first is facts, the one is measures, the third thing is the dimensions. The measure thing is like the data. We classify the data, whether it's infected data or whether this is like date data or whether this is vaccine data, whether this is infected, like gender-based infected data, or age-based infected data. So we have to know this. So this type of data, we call it measures. And this data is the data are classified based on this, and that's kind of measure things. And then after that, we go to dimension. There's two dimensions here. The first one is time dimension and time period type, whether the data is daily or whether the data is weekly, or we can also put like monthly. And the other one is kind of a spatial dimension. In which region this data is available. So in Germany, for example, there are 4 states. The lowest one is Gemeinde, and go up is Kreise, and go up is Bundesland, and after that is nations, right? And then we have to know what kind of this data, where do we get this data? Is it data for the Gemeinde, for example, for Meissen? That's the data for Meissen. And then the region type. So in region type, we know that in Poland, there are also a type of region. They call it, like, the lowest one is Gmina, and after that is Powiat, and after that is województwo. In Czechia, it's also the same. The lowest one is Obec, and the go up is Orb, and after that is Okres, and then Kraj. So this also can be applied to every nation. So in order to analyze it, and then after that, after these three things, we can make kind of the SQL syntax in order to connect between the data. So when we have the data of daily data, for example, it can be aggregated to weekly, or to monthly, or to yearly. I mean, when we have the data of Gemeinde, the lowest one, or then when we have the data of Gmina, we have the data of Obec in Czechia, or any nations, like in my city it's called Kelurahan. Yeah. We can also raise it to the top, the data, and accumulate it and provide it in precise way. And based on that that model, so now the process becoming like this. It's not like everyone download again the file, the CSV file from the source, but it transferred to the PostgreSQL database, and everyone access from here. And I am, as the data manager, provide provide the solution for based on the inquiries from the user. The user itself is our data science. Yeah, and the way we developed the script for the extract transfer load is it like this. For example, there is inquiries from user as is you, and putting like in GitLab, yeah. And then we build a script based on the inquiry. We put in develop stage, like in usual developing. And when everything is fine, there's no more bugs. There's after like 3 continuous tests, 4 continuous tests, and everyone agrees, we merge it to master. In master, we control again. Was like we put in version control and transfer to develop, and script test for Unix and Windows, and we test it in Docker. We first test it in Docker because the machine that Helmholtz have and the machine that Helmholtz provided is really a Unix machine, so we have to test for Windows and Unix in Docker environments. And then after that, everything is ready, then we make kind of automation synchronization in virtual server. So daily transfer and stage database, and also don't forget to test to make a memory test, because we transfer many like lots of data. So the test of memory has to be performed before we switch it to the production test, to production stage. What I mean. Yeah, and also after this, the next one is the forecast process. The one which is manually which is automatically performed is the weekly one. And also the data science also developed this based on R library and Python. So at first there's inquiries as well based on the data set that we have. The data set also is automatically update and daily update. And then we switch in develop stage, and then after that we improve the algorithm and something like that. And then after many tests, and which convinced us to let them in the master stage, to let them run without any problem, and I switched to the master one. And this will be an automatic synchronization, so in also in the pipeline in the server. So that's the overview of the daily pipeline from the data integration. It's also the forecast as well. It is performed automatically, and also, of course, that in this automatic pipeline, we set kind of the error tolerance. So when when the tolerance like the error tolerance exceeds the threshold that we set, then it will send a warning to us, and then we will see what happens there. Why? What do we have to improve this? What happened? Is it the problem of the method or the problem in the data? Because sometimes also, yeah, from the source as well, we have to really check what happened, whether they changed something or something like that. And then, of course, like this is kind of so the user who can access is only the one who have the Helmholtz-Zentrum, the central center of account. This is like normal, but yeah. And then after that, this is the example of the forecast, and yeah, for Sachsen, for example, we can see it. And share the test here, and this is kind of the you can see like here, and then and also there is a calculator here. You can also determine, I mean, it's out of my my talk, but in our website also we determine we make kind of calculator which determine the number of employee who can enter the office, what is the capacity of the office, and something like that. And then yeah, so that's the things. And this is kind of analyzing of Bremen also. But what I want to show is like what I want to show is like also the Jupyter notebook. So with this kind of, I mean, so I use R, so you can see. Sorry, so I will just move it here. You see my screen, or just a small the Jupyter notebook?
Oh, if I make it full screen, I can see it.
Okay, so make it bigger. So this kind of the R script, and you see that there's many view here that which is used by the data science. And I also, as a scientist, can also apply them in my method without just downloading and pre-processing again. And then it's sorry, so I haven't. This is, for example, you can just see directly now what happens in the February. This is weekly data in 20th February. Or for example, you want to see something a lot for Bremen case. Wait. See, here is too much. Or in Poland. Well, let's go to the Bremen case. There's also Czechia. This is Poland. Yeah, and there's also things that I tested. For example, this is we can see that what happened in Bremen at the moment. This one. And, oh, this one has to be changed because now it's 2023. No. It's Bremen hospitalized, and this plot Bremen, which you can see here. What happens Bremen is like, of course, like many people before, when Omicron just started to spread, they just this is the Omicron one, when the green one, but now it just go down, right? I mean, Omicron recover quite quickly, and then yeah, we can see now it's in February. Of course, like we can also test later, see with the forecast. But I'm going to show you what happened in Sachsen. Happened in Sachsen here. This is like 23 now. here. What happened in Sachsen? So also Sachsen has now like lower things. Like this one is the dead rate in Sachsen. The one it's the seven incidents case for per week. Yeah, 7 days. 7 days incident for the dead one. You can see that. I mean, also the, and this is the hospitalized case. Also, the hospitalized case is so low, and in the period of November and December, when the Sachsen has really low vaccine rate, it doesn't decrease their death rate. I mean, there are many, like all people like above 60 still pass away. That because of the young one from 19 until 60, they have the tendency not to be vaccinated because of any reason, which is I don't understand as well why. And from here we can also see which age like died, mostly died in Sachsen. Take some time. Okay, now it's okay. Like 23rd, but the Sachsen like 23rd as well. See here, so you can see like the red one is like 80 plus, yeah, and the black one is 60 until 79. So most of people who die due to COVID is still the old guy, the old man, because the vaccine rate is not really high there. And we also analyzed for the Bremen, but actually I think I exceed 30 minutes. Yeah.
Yeah, you have like 3 more minutes and then maybe time
yeah, and then 3 more minutes. Okay, then. So with this kind of things, we can also see directly what happens quickly. And also, for example, this is the forecast things. The forecast has, was performed. Like this is, this is for test Czechia, and as well, like for example, for this Czechia things, we use like Arima Holt model. This is kind of automated regressive moving, average, integrated moving average. So this is kind of the result that we get, and in the following weeks, in 4 months, in four more weeks, the tendency in Czechia goes down, and also the hospitality goes flat, and in Sachsen also will go down because it starts to go down again, but not really go down quickly. And in Poland, I don't know what happens. The data it just tend to zero, which I still suspect like they delay the inserting of data. So that's all I think from me. Probably, yeah. If you have any question, just please.